Welcome back to Mrs. Cox's classroom. Well, good morning. This is my beginning of the year review day 9. And this one I actually added this last year just because I thought that there was this one more area in math that I wanted students to focus on again for our beginning of the year review. And that was just about area and perimeter of a basic rectangle and square. I just want to make sure they were kind of solid on that as we took off. So I'll share my screen. I'll show you the assignment I assigned in Get More Math, and then I'll teach the lesson. So I'll log into my Get More Math, and I'll go to work. And 7th grade, beginning of the year. And here is my beginning of the year review, day 9. And this is just classify polygons based on the number of sides, determine perimeter, and then given sides of a rectangle, determine area. And so pretty basic. This is something I wanted to kind of have steady in their heads, because again, you know, there's a point where we do that pretty heavy in 7th grade. And so I just assigned that. So I'll go to my student Get More Math account and we'll take a look at those. And here's my beginning of the year, day 3. So the first one is find the perimeter of the rectangle. This is skill code 1040092. The next one, which of the following is true for a rectangle? And it's just making sure that they understand the ideas of rectangles, squares, triangles, parallelograms. Skill code 1133001. And then the last one, find the space inside a rectangle, which again is area 1040012. And so those are the 3 skills that I'm teaching in that lesson. So today what we're going to be doing is we're going to be looking at some formulas for rectangles, squares, and parallelograms. And so we're going to take a look at what perimeter is. When we talk about perimeter, what we're actually talking about is the measurement of the outside of the shape. So I want to make sure that you actually write that down in your notes. So this is the measure of the outside of a shape. And so, you know, you watch a war movie, they're always talking about the guard has to march around the perimeter to make sure that the perimeter is secure. They're just walking around the outside edge of whatever the area is that they're trying to protect. And so we have a rectangle right here. And so the perimeter is just going to be just adding all these sides all up, okay? So we have this side 1 right here, and this side 1, and we know they're the exact same, right? So this measurement and this measurement are the same. That's what these little marks mean. They just mean that whatever this measurement is, it's the same here as it is here. And then we have this one right here, which is side 2. We also call this the base, and we call this the height. Now, I also know that you learned it as length times width, and that's okay to use those 2 terms. I want you to start getting used to the terms base times height, because we're going to be using those in all of our other formulas. As the more complicated formulas go, base and height are used more than length and width. So I understand you understood this as length times width. I want you to start seeing it's base times height, okay? And so for the perimeter is going to be 2 of the bases plus 2 of the heights. Or another way we write this is it's just 2b plus 2a. And that's for a standard rectangle. Now, if this was a square, all the sides would be the same, right? So all these side measures would be exactly the same. And so the perimeter here would just be 4s, because all the sides are the same. And so that's the perimeter of a square. A parallelogram, it's going to be actually the sides. So for a parallelogram, because again, we're just wanting the measurements of the outside. And so you have your side 1, which is the same here. These 2 are the same. That's your side 2. And so your perimeter here is going to be 2 times side 1 plus 2 times side 2. And that's how you find the area, the perimeter of a parallelogram. Now for area of these shapes, the formula for the area of all 3 of these shapes is exactly the same, okay? So you have a rectangle here. When you're looking for area, that is the measure of the inside, okay? So area is the measure of the inside of the shape. So we're looking for area, we're always looking for that inside measurement of the shape. So we have a rectangle. And the way we're going to find that inside measurement is we're going to multiply the base times the height. And so again, just make sure you understand these. The base is just one side of your shape, okay? The height is a perpendicular measure that measures the distance from one base to the other. So here's one base, here's the other base. Here's a perpendicular measurement that measures from here to here. It happens to be the side of this shape as well, but the actual real true definition is the base times height. Height is a perpendicular distance, so it's going to make a right angle right here, so a 90-degree angle right here in the corner, and measuring from one base to the other, and that's called the height. And so the formula for the area of a rectangle, a square, or a parallelogram, area is equal to base times height. And so when you look at a parallelogram here, so you have this parallelogram, and here's the base, and the height here is going to be a perpendicular distance that measures from one base to the other, and that's a 90-degree angle. So there's your height right here. And so it's a little bit harder to find in a parallelogram, but just recognize that the measure, and that's why we want you to understand height and why we want you to switch thinking about a rectangle as just length times width, because we want you to see base times height so that you can see it over here too. Here's the base. The height is this measure right here. It's a perpendicular line, makes a 90-degree angle that measures from one base to the other. That's called the height. And so a lot of times in a parallelogram, you'll see it as a dotted line in the picture for you. And so the formula again is base times height. And so you want to make sure you have all of these notes. And if you need to, you can go ahead and pause this and get this all written down, because this is going to be pretty important. So again, perimeter is the measure of the outside of a shape. Area is the measure of the inside of a shape. Okay, so that area would be just measuring all of this here on the inside, right? And then next we have the formulas for triangles. And so the first one, of course, is perimeter again. And the perimeter is the measure of the outside of a shape. And so it's the exact same idea. Just for a triangle, it's going to look a little different. So I'll draw a triangle right here. And so it's going to be that measure of side 1, here's side 2, and here's side 3. So perimeter, here's another one. Here's side 1, side 2, side 3. Here's another one. Here's side 1, side 2, side 3. And the formula is just going to be side 1 plus side 2 plus side 3. And you just add those all up. It's actually pretty rare in math that we ask you for the perimeter of a triangle, but if we do, that's the formula. And the next one's going to be the area. Now, area is the measure of the inside of a shape. Okay, so it's the exact same definition for the area of a triangle as it is for the area of a rectangle. So in order to get this kind of idea, what I want you to do is I want to start with a rectangle. Okay, so we have a rectangle right here, and we know that the area of the rectangle is equal to base times height, right? So the formula is just A is equal to base times height. Now I want to show you something kind of cool. If I took this rectangle, I could actually make two triangles by just cutting it directly in half. So I draw a line diagonally across the rectangle, and I've now cut it into two triangles. So to get the formula, I just kind of think about this. Well, the formula for a rectangle was base times height, but for a triangle, that would give me two triangles, and I only want one. So to get that area of a triangle, I'm going to divide it by 2. So the area of a triangle is equal to base times height divided by 2. And again, in this triangle right here, this would be the base. Here's the 90-degree angle measuring from from the base to the opposite angle. Okay, so that's how you look at that. So it's going to go from the base to the opposite angle, the angle that's not part of the base, right? This angle is part of the base. This angle is part of the base, and this angle here is not. So it's going to be the base times the height divided by 2. And so if I had this triangle right here, here's the base, and for the height, it would have to be a perpendicular line that measures from the base to the opposite angle. And so we'd see a dotted line right here showing the perpendicular mark, or the 90-degree angle right here, and that is the height right there. Now, sometimes for a triangle, the height is actually found outside the triangle. For example, So if here's the base right here, and here is that opposite angle. And so what I would have to do is I'd have to extend this base out here to get a perpendicular mark right here, to get that perpendicular line that goes from the base to the opposite angle. And so the height here is actually found outside the triangle. So you have to be really kind of careful in how we do that, okay? So sometimes the height is right here as one of the legs of the triangle, like in a right triangle. Here you would see that we could measure the height on the inside of the triangle going from the base to the opposite angle. Here we measured it going from outside the triangle, but again, it's still, we just extended our base so we could create a perpendicular line that went from our base to the opposite angle, and that gives us that height again. So the formula for a triangle is area is equal to base times height divided by 2. And I think that's all you're going to need in order to do your Get More Math today. So let's start looking at some of the problems that you have today, and we'll take a look. So the first one, they just want to know which of the following is true for a rectangle. So the diagonals do not always bisect each other. Well, I'm not sure if that's true. I could draw a rectangle right here, and if I draw diagonals, I think they're always going to intersect. So I think we can get rid of that one. It must be a rhombus. It is a parallelogram. Its four interior angles are not always congruent, and that's not true. The actual definition of a rectangle is that we have the two parallel sets of parallel lines that meet at perpendicular lines, which create 90-degree angles. So the interior angles of a rectangle are all exactly the same, all four of them. So we know that's not true. It must be a rhombus. I don't know if it must be a rhombus, but it is a parallelogram. And a parallelogram is just two sets of parallel lines that intersect and create a shape. And so a rectangle is a special parallelogram. So this would be the correct answer. A rhombus is just another special parallelogram. So a rhombus is a parallelogram, the same as a rectangle is a parallelogram, a square is a parallelogram, a kite is a parallelogram, because they all meet that exact same idea, right? They have it's a four-sided shape, right? Four-sided shape. Rhombus is just a diamond, right? All four sides are the same. Find the perimeter of the rectangle below. So we need the formula for the perimeter of a rectangle. And the perimeter for a rectangle is 2 side 1 plus 2 side 2s. And so we'll just go ahead and substitute what we know, okay? So I know the side 1 is 7, so it's going to be 2 times 7 plus 2, and then the other side is 9, 2 times 9. And then 2 times 7 is 14. 2 times 9 is 18. And when I add those two together, well, 8 plus 4 is 12. So I'll put down the 2, carry the 1. 1 plus 1 plus 1 is 3. And then I have to use the unit of measure. It says label required, so I must write feet or I will get it wrong. So the perimeter is 32 feet. If I was to measure that all the way around, that's what I would get. 7 plus 9 is 16. Plus 9 more is 25, plus 7 more is 32. The next one wants you to find the space inside a rectangle. So we're looking for the inside a rectangle. That's called the area. So we're looking for the area. And I know that area is equal to base times height or length times width, right? And it says it has a width of 10 and a length of 16. So it's going to be 10 times 16. Whenever I multiply any numbers that have zeros, what I do is I just offset my zeros to the side here, and then I just drop them, and then I just start multiplying. 1 times 6 is 6. 1 times 1 is 1. So the answer is equal to 160. And it says label is optional, so you won't get marked down if you don't write the label. But since they didn't give us a unit of measure, then we would just use units. And we would actually multiply units times units, just like we multiplied 10 times 16. And so units times units is equal to units squared. And so we would put that squared mark right there. So the next problem wants you to find the perimeter of the rectangle below. So we're looking for perimeter again. So perimeter is equal to, and again, this is a rectangle. We're going to have 2 times side 1. So 2 side 1s plus 2 side 2s. And if we notice, we see that they're actually the same. So this is actually a square. And so I know that because those are the same, this is just 4s, right? So I'm just going to substitute. That's going to be 4 times 27. And 27 times 4. Well, 7 times 4 is 28. So put down the 8, carry the 2. 2 times 4 is 8, plus 2 is 10. So we get 108. And so the answer is 108 centimeters. The next one asks you a rectangle has a width of 11 and a length of 8. Find its area. So we're looking for the area of a rectangle. And so that's going to be base times height. Base is the same thing as length, and height is the same thing as width, so it doesn't really matter. So it's going to be 8 times 11. 8 times 11 is 88. And again, it says label optional, so you can type in just 88, or we know that it was units times units, so we get units squared. The next one says, how many sides does a heptagon have? And so just as this idea here, making sure you understand, triangle, because tri means 3, is a 3-sided figure. A quadrilateral is that's going to be your rectangles, your rhombuses, your squares, your parallelograms. They have 4 sides because quad means 4. Pentagon is a 5-shaped, so pent means 5. Hexagon is 6-sided. Hex is what we use for 6. Heptagon or septagon is going to be 7. The hept or sept are both 7. Octagon, oct means 8, so 8-sided figure. A nonagon is going to be a 9-sided figure, and a decagon is going to be a 10-sided figure. So they wanted the heptagon, and that is going to be 7. So you're just going to write 7 right there. So this is a good thing to go ahead and write down too, to make sure that you understand that. And I know for a lot of kids, we get to the month September, and then we have October, November, and December. And these actually do. Sept means 7, oct means 8, the nov means 9 or non, and the dec means 10. And for a lot of people, it's very confusing because they're like, well, wait. This is the 12th month, December. So what happened was when the calendar was first created, it actually started with March. March was actually number 1, and February was the last month of the year. And that's why February was shorter, because it was the last month of the year. It was just those rest of those 28 days. And then every 4 years, to make an adjustment to keep everything lined up, every 4 years we add a day, and we just added it to the end of the year. And that's why we added another day to February. So in the original calendar, September was the 7th month, October was the 8th, November was the 9th, January was the 11th month, and then February was the 12th month. And so these were right in line with our actual numbering systems. And so there's that. That should be enough to keep you going for review day 9. I'll see you tomorrow. And then remember, if you're enjoying my videos, please subscribe and like. Thank you.